Mars, our fourth neighbour, has long been a symbol of both promise and challenge. Known for its iconic rusty red colour, Mars has transitioned from a mere mythological light to humanity's most ambitious scientific destination. But beneath its visual appeal lies a world with facts far more extreme than we might imagine.
In terms of size, Mars is a small world, only about half the diameter of Earth. Its total mass is just 10% of Earth's, providing future colonists with a weak gravitational pull, only 38% of what we feel today. Despite its small stature, Mars hosts the largest geological anomalies in our solar system. Olympus Mons, the shield volcano, soars up to 25 kilometers or 16 miles high. It is so vast that if you stood at the summit, its slopes would curve below the horizon, rendering them invisible. Crucially, its massive size was made possible by the absence of active plate tectonics on Mars, allowing the magma hotspot to push the crust in the same spot for billions of years. Valles Marineris. This giant canyon system stretches over 4,000 kilometers or 2,500 miles, more than 4 times the length of the Grand Canyon. It's not the result of water erosion, but a colossal tectonic fracture in the planetary crust, a geological scar from an ancient cooling Mars.
A Martian day, or sol, is remarkably similar to Earth's, lasting 24.6 hours. However, a Mars year spans 687 Earth days. Mars's average temperature is frigid, sitting around minus 63 degrees Celsius or minus 81 Fahrenheit. Its atmosphere is incredibly thin, composed of 95% carbon dioxide or CO2, and has pressure too low for liquid water to last on the surface. This is the result of the loss of Mars's global magnetic field billions of years ago, which allowed the solar wind to strip away its atmosphere layer by layer. The most compelling fact about Mars is its wet past. Some 3 to 4 billion years ago, Mars was a different world. Geological data collected by rovers and orbiters clearly indicate ancient river networks and deltas. High-resolution imagery shows extensive valley networks and layered sedimentary deposits that could only have been formed by large amounts of flowing water over long periods. Signature minerals. On Earth, these minerals form only through prolonged interaction with liquid water. Their presence on Mars is definitive proof of ancient lakes and possibly seas. The loss of the magnetic field led to atmospheric escape. Without sufficient atmospheric pressure, liquid water could no longer exist. Most of Mars's water wasn't lost to space, but became trapped in a frozen state. Today, Martian water is locked up as water ice in polar ice caps, layers of ice several kilometers thick. Subsurface ice, the amount of frozen water buried beneath a few meters of regolith, is estimated to be equivalent to Earth's Arctic Ocean. With water present in the past, did microbial life ever emerge on Mars? This is the focus of modern missions. The Perseverance rover is currently exploring Jezero Crater, a former river delta, to search for biosignatures, the chemical or morphological traces of ancient Martian microbial life. The rock samples Perseverance is collecting will be the core of the Mars Sample Return mission, slated to bring these critical specimens to Earth labs for deep analysis in the 2030s. The history of confirmed Martian facts has been written by a fleet of robots. Rovers don't just take pictures, they conduct complex chemical experiments. Opportunity 2004 to 2018, designed for a 90-day mission, it operated for nearly 15 years, covering 35 kilometers. Its discovery of spherical hematite, dubbed blueberries, was one of the strongest early pieces of evidence for ancient water. Curiosity, 2012 to present, focused on habitability. Could the Martian environment have ever supported microbial life? The answer was a resounding yes.
Link complete. Hull secure.
Confirmed. Activating telemetry now.
Ingenuity, the Mars helicopter, an amazing feat of engineering. Its mission was to prove that flight in Mars' 1% thinner atmosphere was possible. Its success opens the doors for future aerial exploration by humans. InSight seismology lander, dedicated to the planet's interior. By listening to Mars quakes, InSight provided crucial data about the size and composition of Mars's core, mantle and crust. The most vital technical fact for colonization is the success of the MOXIE instrumental aboard Perseverance. MOXIE successfully takes carbon dioxide, CO2, from the Martian atmosphere and converts it into oxygen, O2, through electrolysis. This is a critical ISRU technology. The oxygen produced is not just for breathing, but also serves as an oxidizer, fuel, for the return rocket.
Mars has no rain, but it does have powerful winds and storms. The unique fact here is that Mars occasionally experiences global dust storms, where rusty red dust completely envelops the entire planet for weeks or months. While these storms are not overly destructive to hardware, they block sunlight, which was a massive problem for solar-powered rovers like Opportunity.
Mars has two small, strange moons, Phobos and Deimos. Unlike our large round moon, these are irregularly shaped and are likely captured asteroids. Phobos has a dramatic fate. It orbits incredibly close to Mars and is slowly spiraling inward. In approximately 30 to 15 million years, Mars' gravity will tear it apart and the debris will form a spectacular dust ring around the red planet. A lesser-known visual fact is the phenomenon of blue sunrises and sunsets on Mars. On Earth, the atmosphere scatters blue light, letting red and orange light pass. That's why our sky is blue. On Mars, the fine rusty dust particles scatter the red light, making the daytime sky reddish. At sunset, the reverse happens and the blue light becomes dominant near the horizon. Despite our technology, the facts confirm Mars is a deadly environment for humans. Beyond the distance and extreme temperatures, the biggest challenge is radiation, the ultimate threat. Without a magnetosphere and the thick atmosphere, astronauts must shelter in habitats buried under the regolith, Martian soil, to avoid lethal levels of cosmic radiation. Toxic dust,
The Martian dust contains poisonous perchlorates,
something.
which can be
The
harmful to
spectrometer readings are
humans
off
and
the
other
charts.
organisms,
Copy that.
and containment will be
Deploying
a
the sensor
daily risk for colonists. The race to Mars is dominated by two massive visions. NASA, the Artemis path, a measured step-by-step approach, using the Moon, the Artemis program, as a crucial testing ground for habitat, life support and ISRU technologies before launching astronauts to Mars in the late 2030s. SpaceX, the Starship path, Elon Musk's ambitious vision to use a fully reusable Starship rocket fleet to send cargo and, eventually, self-sufficient colonies to Mars, aiming to make Mars an inhabited second planet.
While currently a long-term ambition, the ultimate vision is terraforming, the transformation of the Martian environment to be more Earth-like. The major hurdle remains re-establishing a magnetic field. Without it, any atmosphere we add will eventually be stripped away again by the solar wind. Terraforming Mars with our current resources and technology requires millennia. Yet it represents the pinnacle of ambition to turn us from visitors into true permanent inhabitants of the Red Planet.
All these facts, from giant mountains to lost water, paint a picture of a beautiful yet harsh world. Mars exploration is not just about seeking another life, it's about securing our own life. Mars is a mirror reflecting humanity's resilience, ambition, and perpetual desire to go beyond our planetary limits. In the red soil of Mars, we will find not only the past of another world, but also the future of our own species.
Plate, this is Eris 1. I have visual confirmation of the colony structure. ETA, approximately 15 minutes.